I was learning how to conduct an animal model of injury known as the trauma hemorrhage model, which is meant to mimic a wound an animal or a human might sustain that is followed by severe blood loss. The surgeon teaching me always conducted the procedures on at least 2 animals in a given day. One would receive only the wound, and the other would receive the wound plus blood loss. The first animal was anesthetized and received the wound, which was an incision that was then closed with stitches. Then the arteries would be catheterized to monitor blood pressure and to initiate the blood loss. If the full procedure was successful, then the second animal would receive only the wound. However, if they were unable to cause the blood loss, the first animal would be switched to the wound-only group, and they would try for the wound plus blood loss on the second animal. Unfortunately, the surgeon was introducing confounders into the model. For instance, if the inability of the surgeon to successfully complete the blood loss in an animal was not random chance, but instead was something different about the animal, such as differences in vasculature or musculature, the surgeon was systematically putting these animals in one treatment group compared to another. Similarly, if there was an order effect, it would be repeated in every experiment except for the ones where the procedure was not completed. An order effect can occur if, for instance, the surgeon behaves a little differently from the first to the second animal. The fact that the surgeon had a second animal available may have introduced such an effect. The surgeon may have tried harder to make the procedure work on the second animal because there were no more waiting. Similarly, the fact that the second animal had to wait an additional amount of time could cause some of the differences because of differences in animal physiology across the day, such as chronobiology or fasting time. Most of the differences between the wound or the wound with blood loss groups were large, so this difference did not necessarily undermine all of the studies. But especially for smaller outcome effects, the fact that there were systematic differences between the treatment groups besides the conditions of interest raises the possibility that the confounders, and not the conditions themselves, resulted in between-group differences.
So how can we learn from these mistakes? Ideally, the animals would be randomized, assignments concealed, and all parties blinded. However, with something as obvious and extreme as a surgery, that is not always possible. So a good start would be to randomly assign each animal to a treatment and an order, and stick to it. For animals that could not have both the wound and blood loss completed, they should still be continued as assigned. Information on whether there is a difference between successes and failures might provide insights into natural variability, which could be an important source of future hypotheses. Of course, the exact protocols will depend on the experimental design and animal care approval, but randomizing animals and sticking to it helps to remove some potential confounders, making the experiment cleaner and more reliable. And, if you have any questions, consult your friendly neighborhood statistician.